This last part will talk about how your work should look for expressions versus equations. Just first of all, recall that an expression is notation representing a number, and an equation is a statement that two expressions are equal. So here's an example expression, 60 minus 10 times 4 squared plus 8. Here's an equation, 3x plus 2 equals 14. Expressions versus equations, these are really different things. You'll notice that in the equation 3x plus 2 equals 14, to the left of the equal sign was 3x plus 2, which is an expression. To the right of the equal sign is a much quicker expression to write, just 14. And when you take two expressions and you stick an equal sign in between, you get an equation. You have to keep track of the difference between expressions and equations. And the distinction between these two is very important that we get the habit early on. The main task for expressions, in fact, and the main task for equations are usually very different. The way that work is organized for these two tasks is also very different. So the typical task types look like this. For an expression, it's usually simplify the expression, and for an equation, it's usually solve the equation. This isn't always the case, but these are, for now, let's just say those are the main, the key tasks. For expressions, you simplify, for equations, you solve. And how the work, again, so not only are the tasks different, which we're pointing out right here, the way the work is organized looks very different. So to simplify the expression, 60 minus 10 times 4 squared plus 8, this will be the start of our answer, and we're going to actually present the answer two different ways. So this is answer one. Just they look different. So what we'll do is after writing an equal sign, so I copied the original question or the notation content of it, 60 minus 10 times 4 squared plus 8. Then after an equal sign, not an arrow, but an equal sign, then start simplifying. So we'll follow the order of operations. So the 4 squared happened first. That's why there's a 16 here now. And now scanning from left to right, oh, well, sorry, we've got a multiplication. That's going to happen before the minus and the plus happen. So let's do 10 times 16, which will be 160. Copy the rest of this. For this equals to work, we still need to account for, there was a 60 and a minus sign. So you see still written here is a 60 and a minus sign. Otherwise, this equals wouldn't be true. So we really want what's written from here to there to be equal to what's written from this 60 to that 8, and then equals, after this equal sign, there's a 60 minus 160 plus 8. So these really are truly all equal. And now, let's see, all the multiplications are done, so we should do subtractions and additions from left to right. So we've got to do a subtraction first, and then finally simplify negative 100 plus 8. You'll get negative 92. So this is one way to organize the work. Basically, after an expression is an equal sign, and then you write down another expression, which is equal to the previous expression, just more simplified. Here's a second way to organize the work. This second answer isn't actually morally different, it just visually looks different. So it starts the same, the original expression here, and then still after an equal sign, write down your next step. It's the same work that was up here, it's just written vertically, that's all. And then after an equal sign, here's the next step, and after an equal sign is negative 100 plus 8, and after an equal sign is negative 92. So answer 1, answer 2, they're the same. Just do whichever's more comfortable for you, or in some cases what's more convenient based on the shape of the problem. The thing is, I want to point out this method specifically right now with the equals, sort of this vertically stacked, this answer 2 that has 1, 2, 3, 4, 5 lines of work. Notice where these equal signs are located. They're located to the very left before you start writing the new expression. And yeah, work for expressions can be written horizontally or vertically, like in answer 1 or answer 2. An equal sign, not an arrow, is required between steps. The thing is that expressions must be equal. That is, for instance, look at what's highlighted in red right now. 60 minus 160 plus 8 truly is equal to negative 100 plus 8. And you'll see that both in answer 1 and answer 2. If you leave off the plus 8, so in red it says negative 100 plus 8, and if you leave off the plus 8, then what you have isn't going to be equal, right? So just because a part of the expression isn't changing, that doesn't mean you don't copy it down. To account for everything and for equals to truly mean equals, you've got to still write it. And I know it takes extra writing and it's time consuming, and sometimes students focus on just writing the part that's changing, But the the bigger that the expressions get, when you start with, it becomes harder to keep track of all the pieces if you just write down the part that changes. So from one step to the next, really account for the entire expression. Sometimes people only write the part that changes. So writing, for instance, 60 minus 160 plus 8 equals negative 100 is incorrect because of the missing plus 8. So just keep in mind, equal doesn't mean the next step. Equal really means equal. So that's why after an equal sign, what you write has to be equal to what was there previously. How about solving an equation? Let's, as an example, look at 3x plus 2 is equal to 14. Now, we haven't really talked much about how equations are solved, but you may be familiar with doing the same thing to both sides. Now, what I'll do, just for the sake of this answer, because there's so few answer steps, I actually just recopied the question. Generally speaking, when you're working on things, you can skip rewriting the original equation. So I will subtract 2 on both sides, and you'll notice one line down, I have this equation, 3x equals 12. The equal sign's in the middle. Then one line down, dividing by 3 on both sides, I'll have x is equal to 4. Here's some comments. You must write vertically here. Below one equation is the next equation. You might, after some time, if you're running out of room, find a way to write horizontally a bit, but for now, the problems will remain small, and I really insist that you write vertically, one step, and then one line below, write down the next step. Notice that in each line of work, the equal sign is in the middle. What does this all mean? So let's take a look at what's highlighted in red. From the given fact, we were told that 3x plus 2 is equal to 14. From that given fact, by doing something, namely in this case we subtracted 2 on both sides, we get the fact that 3x is equal to 12. That's what's going on. One equation leads to another equation. Here's some incorrect work in the red box. 3x plus 2 equals 14. Next line equals 3x equals 12. Next line equals x equals 4. The problem is, notice the equal sign that's highlighted in red currently, as along with the other text in red. So this is currently suggesting that 3x plus 2 is equal to 3x, but those aren't equal. Actually, 3x plus 2 is 2 units bigger than 3x is. And actually, though it's not highlighted here because there wasn't more room on the slide to talk about it, same deal. One line below, 3x, there's this equal sign, in the sort of lower left corner of the red box. 3x isn't equal to x, and that's what's suggested by that equal sign. So these equal signs that are on the very left of a new line, these come about from that sort of second answer style that we just saw for expressions. But for equations, you just really want an equation on each line, which means there will be an equal sign somewhere in the middle of each line of work. So not only are expressions and equations different, presenting work for simplifying an expression and presenting work for solving an equation look rather different. So just to take the work that we already saw and just so that we can see them side by side in the slide, here was earlier simplifying the expression, and I've chosen what earlier we called answer 2 because it's the one that's going to look most similar by being written vertically stacked with one line of work down from the previous line of work and so on. And here was solving an equation. And you'll notice the difference is that for an expression, each new line down starts with an equal sign because we're trying to say the new expression is equal to what was written previously. Whereas for an equation, we're just saying here's an equation, and then on the next line, here's the next equation. And from that equation, by doing this something on both sides, here's our next equation, x is equal to 4. For your interactive question for today, identify at least 3 differences between expressions and equations, or identify differences in how the work is presented. How does the work look different?